In 8.3, we're still working with rational expressions. We are now adding and subtracting, which is a little more difficult actually than the multiplication and division. Remember that they are fractions. So all fraction rules are also going to apply to these. To add and subtract fractions, you need to have a common denominator. So I need to get the denominator of these two fractions to be equal. And it's helpful to factor them first if you can. The 12x plus 4, I can factor out a greatest common factor of 4, and that becomes 3x plus 1. So they already have the 3x plus 1 in common. That part is already the same. This one has a 4 in the front, this one does not. So you can't add to make common denominators, but you can multiply. So I can multiply by a 4 if I also multiply the numerator by 4. So I'm going to multiply the top by 4 also. I'm going to rewrite them. So this one becomes 4x minus 5 over 4 times 3x plus 1 plus, I'm going to distribute on the top because when I add I want to be able to combine like terms. So I'll distribute the 4 through, even though I'm not doing it that on the bottom. On the bottom I factored it out, but again I want to be able to combine like terms, so I'm going to actually distribute it in on the top. 4 times 3x is 12x, and then 4 times negative 1 is minus 4. When you add fractions, once you get the common denominator, that doesn't change. That stays the same now. So the denominator is going to be 4 times 3x plus 1. On the top, we're going to add, and to add, you add like terms, combine like terms. So I can add the 4x and the 12x. That's 16x. And negative 5 plus negative 4 is negative 9. Now, just like before, if you want to distribute that 4 back into here, it probably would look a little bit nicer. That to me is not the most critical part at this point. When we were multiplying and dividing, we actually left it, but that would be 12x plus 4. It looks a little bit nicer. It looks the same as the top now, so it looks better, but that's not the part that I'm most concerned about. So the good thing is that when we go to do the subtraction now, it's the same type of problem. There's no difference in what you do other than whether you add like terms or subtract like terms when you're finished. So these also need common denominators, and this is one where a lot of mistakes get made because they both already have the 2x. So people somehow want to subtract 3 from that one or somehow multiply by a negative, but in fact this is entirely different than this. So this fraction actually needs a 2x minus 3, and this one actually needs a 2x plus 3. You can't just change the 3 without changing the 2x also. You can multiply the whole thing by something, you can't add or subtract. So I'm going to multiply this by 2x minus 3, and if I multiply on the bottom, then I also have to multiply the top by 2x minus 3. On the right hand side, I'm going to multiply by 2x plus 3, and then multiply the top by 2x plus 3. So I'm going to distribute out the tops like I did last time and rewrite them. X times 2x is 2x squared, and x times negative 3 is negative 3x. Minus. On this one, make sure you have to FOIL, so you have to distribute the 2x to both of those and the 1 to both of those. And you will get 4x. So those two make 2x, those two make 6x. When you add them, that's 8x. I didn't write these in the same order, that's okay. They still are the same. You're multiplying. You can multiply 2 times 3 or 3 times 2 in either order. They still are the same. So now I can go through and subtract like terms. I can subtract 2x squared minus 4x squared, which gives me negative 2x squared. Negative 3x minus 8x is negative 5x. Oops, excuse me, negative 11x. And then there's nothing to, there's no constant here, but I'm still subtracting 3, so it's still going to be a negative 3. That's a negative 11. And then on the bottom, you could leave it. You could, remember the bottom's just going to be the same as those two, so you could leave it like that, or you could multiply them together and get 4x squared minus 9.